So let us start introducing a couple of concepts that we will use in order to walk you through some of the features of the product we are going to showcase today. And an IoT solution made simple and open, integrated, and managed. So the first part is we were talking about open source, open standards, and open hardware. Just a little step back and talk about Eurotech. It's a company that has been around for 20 years. It started with the embedded systems, and it has been an evolution from the hardware part. So we definitely come from the IT part of the OT, IT integration. There has been an evolution, and we decided and we realized that connectivity was one of the most important parts in the offering. So we started providing the software solution apart from the hardware products in there. The verticals, we actually provide solutions in a pretty wide extent of verticals, from industrial to transportation, defense, and healthcare. This is a pretty typical stack of the IoT architecture, and Everywhere IoT is our name for the combined implementation from a solution that goes from the devices and sensors and constrained devices from the bottom, connectivity to the gateway in the middle, and in the middle you can see the Everyware software framework, which is the Eurotech middleware for IoT gateways, and then Everyware Cloud, which is the Eurotech IoT integration platforms that provides connectivity to the IT part and integration to the IT part of the spectrum. And you can see on top all the different applications and business applications that can be connected through these architecture. And here there are some of the details in there. Okay, so one of the first topics we talk about open source. So we see here in close to Everywhere software framework is Kura and Kapua that actually has been already presented by Eclipse. Those are two projects from Eclipse that Eurotech contributed to. The code base was donated to Eurotech. Kura is the middleware for IoT gateways that was donated some 3 years ago. More recently, the Kapua, the upper part of the cloud implementation, was donated last year. There are many contributors to these two Eclipse projects. At the center, Eurotech and Red Hat, of course, and contribution from IBM, Microsoft, Oracle, Intel, Bosch, and GE. So these two projects are actually inside the IoT working group of Eclipse. The IoT working group was founded in 2012 by 3 companies, Eurotech, IBM, and Sierra Wireless. And you can see that is one of the most active projects inside the Eclipse community. Here are the code contributions, and you see that Eurotech definitely it's together with the open group of communities is definitely one of the biggest contributors to the IoT working group at Eclipse. And one topic for which Eurotech is not very well known, but actually it's one of the founders together with IBM and developers of the MQTT standard that has become an OASIS standard last year. It's Eurotech, and here it's one of the open standards, one of the many open standards that we adopted in our solution. And open hardware, that was the third topic that we want to introduce. So at the gateway level, this middleware for multi-service gateway, we see that ESF, which is based on Kura, Eclipse Kura, can be installed, and actually we provide distributions of that for also open hardware like Raspberry Pis and BeagleBones, all the way to our devices and gateways in the middle. all the way up to industrial ruggedized gateways on the top. The next topic is integrated. And we will divide integration in two parts: integration at the edge, integration at the data center, and see how these solutions are actually modular. This is the previous architecture, and now we will focus on the part in the middle, the middleware for gateways. And well, the title was Simplifying IoT Solutions, and how we do that. Here we are really talking about the core, the most important part of the entire architecture, which is the connectivity at the gateway level from the devices and then up to the clouds. In the new versions of Kura 3.0 that has been just announced, and the ESF product 5.0, we are showcasing wires, which is a way to graphically set up device connectivity and device configuration and abstract protocols that are connected with devices. So in here we see at the middle a little data flow diagram that has decomposed graphically of composing and wiring together some components that are available from a palette of components. And in this way you can specify connectivity using different industrial protocols with some data consumers, and publish the data all the way up to the cloud without writing a single line of code. So this is a zoom in into the wires editing, graphical editing program. It's a data flow tool to compose these graphs. And you can see that you can specify for each component also the connectivity and the channels of data communication, again, without writing a single line of code. These abstraction, it's important because you can actually reuse part of these diagrams across different applications. This is zooming in the core part of the middleware for gateways, and you can see many different parts. One in specifically the addition in this release of drivers and assets. These are the abstractions that allow you to reuse the same concept of, for example, an industrial protocol or a data consumer that you have specified across different applications. Now let us zoom on the second part, the Everywhere Cloud part, and talk about integration at the data center. Here you see from this diagram that there are many, many services and modular services that are that build the Everywhere Cloud part, from the data management of real-time analytics and storage to also the device management. Here it's a sample of the Everywhere Cloud web console, in which you can actually see an inventory of all the devices connected to the cloud. You can see the data that is being published to the cloud and the status and health of all the devices connected. And then finally, the third concept, the third theme that we brought together, which is managed, and managed in three different ways. Managed at the OT level, managed at the IT level, and security of the connection between the two, of the bridge between the two. From IT management, we talked about Everywhere Cloud. We know that is the integration platform that has been contributed to the Kapua project. And now it comes in three different versions. The public version that uses the Docker technology. We also have an on-premise version that can be on a software appliance, or actually on any public private cloud that the client wants. There will be, and it has been announced, that Everywhere Cloud and Kapua can actually run on top of the Red Hat OpenShift stack. Now the OT management is the management at the OT level. So the most important thing in here is that at the cloud level, you can really do remote management of your devices. Secure management of the devices. There is an entire certificate management, a PKI certificate management at the cloud level. Device batch operation, and device provisioning. Device provisioning, and actually, it's one of the most important features of our system, in which there is a handshake between the requester and a device in order to create a secure connection, establish, exchange some certificates, and being able to have the device up and running, connected to the cloud in a secure manner. Another interesting feature is the possibility of connecting from the cloud all the way down to the gateway and down to the device using a virtual private network. And last but not least is actually all the features of security that we provide from the cloud level. We have a full PKI integrated certificate management. We validate the server identity. We validate also the device identities. We can do optional and two-factor authentication for the connections. At the device level, we can actually deploy code that has been signed, and only signed code is going to be executed at the device level. And the communication between the two, obviously we have full encrypted communication and host name verification, which is a typical weakness that can be addressed by middleman attacks. And digitally signed messages. This is an important part because everything that gets communicated, and remember, we are not only taking data from the field, but also we are remotely managing the devices, is sent through and signed with digitally signed messages. Okay, so these were the three themes that we used to describe how our solutions are very simple, open, integrated, and managed. Thank you.